Hello everyone, welcome back to the channel. If you are serious about mathematics, and I mean really serious, then today's book review is for you. We are looking at both volumes of Mathematical Analysis, Advanced Topics by A.V. Efimov, published by Mia Publishers Moscow, a masterpiece from the mathematics schools of the Soviet Union. If you are up for a challenge, these novels are strong, challenging and smart. The author of the book is A.V. Efimov. A.V. Efimov was a Soviet mathematician and professor who specialized in mathematical analysis and differential geometry. His books are less well known internationally compared to authors like Rudin or Apostol, but within the USSR they were highly respected and widely used. The aim of the Efimov volumes was to develop strong mathematicians or students who could read critically, solve problems carefully, and easily understand the fundamentals of analysis. Now let's go through volume 1 of the book. Part 1, General Functional Series and their applications. First published is 1985. So contents. Chapter 1 is Basic Concepts of Functions of a Complex Variable. Chapter 2, Conformal Mapping Determined by Elementary Functions. Chapter 3, Integral Representation of Analytic Functions. Chapter 4, Numerical Series and General Functional Series. Chapter 5, Power Series. Chapter 6, Application of Power Series. Chapter 7, Orthogonal Systems and Orthogonal Series. Chapter 8 is Fourier's Trigonometric Series, Fourier's Integral. Chapter 9, Some Application of Orthogonal Series and Fourier's Integral. Chapter 10, Discrete Fourier Transformation and its Realization on a Digital Computer. Chapter 11, Lorentz Series, Residue Theory. Chapter 12, Operational Calculus. And Chapter 13, Application of Operational Calculus to Solving Criterion Equations of Mathematical Physics. The chapter 1 is Basic Concepts of Function of a Complex Variable. The chapter 2 is Conformal Mapping Determined by Elementary Functions. The 4.3 is certain sufficient test for conditional convergence of numerical series, alternating series. Chapter 11 is Lorentz series, residue theory. Properties of transforms. Now let's explore volume 2. Some stints on the pages. Part 2, application of some methods of mathematical and functional analysis. First published is 1995. Contents. Chapter 1 is elements of vector analysis. Chapter 2, special kinds of vector fields. Chapter 3, certain concepts of functional analysis. Chapter 4, completely continuous operators in non-linear spaces. Chapter 5, self-adjoint operators in a Hilbert space. Chapter 6, fundamentals of the calculus of variations. Chapter 7, certain methods of solving variation problems. Chapter 8 is problems of computation and uniform approximation of functions. Chapter 9, interpolation and its application to problems of numerical differentiation and integrations. Chapter 10, numerical methods of solving algebraic and differential equations. Chapter 1, elements of vector analysis. Some concepts of vector analysis. The vector function of a scalar argument. One point two is scalar field. The concept of scalar and vector fields. Chapter 2 is special kinds of vector fields. 2.1, potential vector field. Notation and properties of a potential field. Chapter 5 is self-adjoint operators in a Hilbert space. Five point two is self-adjoint operators and their properties. Definitions in applications and important rules played by self-adjoint operators, which we have to define now. Let's an operator T mapping D into H be defined on a dense set D in a space as the operator T is said to be bounds on D if there is a constant m greater than 0 such that for all xed the following estimate is valid. Six point two is extremum of a functional, variation of a functional. Chapter 10, numerical methods of solving algebraic and differential equations. 10.1 is system of linear algebraic equations. By 10.2, solving nonlinear equations. Statement of the problem, consider the equations. Somewhere in the last chart. Thanks for watching, and as always, stay curious and keep learning.